Good morning, good afternoon, and good evening, everyone from all around the globe. My name is Eric Mail, and I'll be helping moderate today's webinar on building production applications using Julia. Thank you all for joining us to learn about developing production systems within the Julia ecosystem. In this webinar, we'll learn how to transform your commercial application into a real-time, agile, and robust production application. We'd like today's session to be interactive, so please write your questions in the chat. We'll either address them on the fly or address questions individually following the demonstration. With that said, it's my pleasure to introduce today's presenter, Avik Sengupta. Avik is the author of the book titled Julia High Performance, which has a 4-star rating on Amazon. Avik has a graduate degree in computational finance from Carnegie Mellon and received his MBA from the India Institute of Management in Bangalore. Please welcome Mr. Avik Sengupta.
Thanks, Eric. Thanks for that introduction. I hope everyone can hear me okay. If not, please send us a message on chat. Welcome once again to this session. Thanks for spending your time with us. I hope this is useful to everyone who's here today. For the session today, I want to spend maybe just about half the time through my presentation. My presentation will basically be a set of pointers, right? Because writing apps in production is something that is different for pretty much each and every one of you. You know, what you mean by production, what you have to do to get your applications into production. And so there is, as I'm sure would be obvious to most of you, there is no one single path to getting there. So I want to spend the first sort of half of this session with a few pointers to some of the possibilities, some of the things that are options for you to consider. And then I want to talk to you about what your needs are, what your concerns are, and hopefully we can address some of them jointly for the second half of the session. So that's the agenda for today. I hope you can see my screen where I have my presentation shared. So the theme of today's session is that running Julia apps in production is not science fiction. Julia is a young language compared to, some of the other languages that you may have used before. It's not a 30, 50-year-old language like C or C++. It's not a 20-year language like Java. But yet, Julia is a language that has a pretty long history at this point. It has a wide ecosystem of packages, and it has an extensive history of companies using Julia in very critical applications, right? High performance applications, important applications for uptime. And, we'll look at what it takes to get there to run these kind of applications in Julia. Right? So the first point I want to make today is that production means different things to different people. To some, production is a batch process. So you're training a large model, you start and you end after a few hours, and then you're done. You get your results, and that's it. Or you're running large-scale simulations that take anything from a few hours to a few days, and you start it and then it runs and then it stops, right? And so there is some interactivity, but then your processes run in sort of discrete periods of time. And that has certain requirements which are different from running long-running services, which is the other kind of production that people talk about, right? So you're serving user-facing web services, or you're serving API services, maybe REST or JSON services, and you want to have them running continuously with a high uptime and with low latency responding to requests. And so between these two sort of paradigms, there are different things you need to consider, different reasons to, uh, uh, different reasons for why you do this, and different ways of how you would deploy them, right? To some people, production might also mean desktop UIs, uh, graphical applications that are used individually on people's desktop. And while that is, uh, much less prevalent, it's certainly possible to do that in Julia today, right? So whichever way you want to run your production app, whatever production means to you, I think one of the first questions that you need to answer is, what code am I actually running, right? What is the code that I'm pushing to production? And that is surprisingly difficult question to answer in some situations. So to answer that question, one of the key points to think about that we suggest you consider actively is, are you deploying a library or are you deploying an application, right? Typically, when you are deploying something to production as an end artifact, right? It's the thing that finally runs. You are typically trying to deploy applications. And so some of the uh, instructions that you see online about running Julia packages really work for libraries, packages that other applications or other libraries use as a dependency. But when you're deploying something on its own, uh, you need to think slightly differently. So one of the first instructions that we tell people is that if you have an application, you should always check in your manifest.toml, right? So most of you, I hope, are Julia programmers. You know how Julia packages work. Typically, a package has what is called a project.toml, which declares the dependencies of that package, right? It declares the top level dependencies of the library or the package that you're developing. The manifest.toml is generated from the project.toml, and it contains a snapshot of your entire environment, right? So while project.toml contains only your top level dependencies, and it can contain maybe a version bounds, the manifest.toml contains exact versions of every dependency right down to your dependency leaves. Uh, and so typically we would recommend that for a package, for a library, you only check in the project.toml, because when your end user uses your library, then they instantiate the environment based on what they have installed, the other libraries that they have installed, the other packages that they are installing, right? But for an application, the thing that you're deploying, you should check in your manifest.toml. You should generate your manifest.toml typically in a CI system, or maybe even in your dev system, check it into Git, and then ensure that when you deploy things to production, you use that manifest.toml to instantiate your production environment, right? And what this ensures is that the versions of every library that you have tested with is exactly the same in production, right? So it never is the case that between when you tested and when you actually deploy it, one of your dependencies has pushed a new version in their repository, right? Or in the registry. So you are protected from your dependencies upgrading their versions if you check in your manifest.toml. So when you're deploying Julia code to production, it is important, therefore, to use your manifest well. One of the caveats to using manifest is that generally manifests in Julia are specific to a version of Julia, or at least to a minor version of Julia. So a manifest generated in 1.6 typically can't be used in Julia 1.5, but a manifest generated in Julia 160 can be used in Julia 161. So you need to, uh, firm up the version of Julia that you're testing with, and as well as running in production with. So that's something that you have to keep in mind, that your CI runs the same version of Julia, or at least the same minor series uh, compared to what you run in production, right? So don't test in 1.5 and deploy in 1.6, or vice versa. Test in 1.6 and deploy to 1.6 as well, right? Right. Uh, so the next topic that I want to talk about is the idea of a package compiler, right? So if you haven't heard of package compiler before, package compiler is a Julia package in itself. And what package compiler does is that it precompiles your Julia code along with all its dependencies into a bundle that you can deploy together, right? So it sort of helps you reduce the compilation time latency that Julia code sometimes has, right? So Julia codes, many of you will know, if you use Julia, the first time you use a package, it takes a while to compile that package, right? And then it saves what is called a JI file, which is an intermediate representation of Julia code on disk. And so the second time you load the package, it is slightly faster, right? So sometimes you don't want to pay the cost of that compile time, and package compiler helps you do that. Uh, so package compiler, is a function that you can call, and you give it your project and manifest, and with some options, and it'll then create a bundle that contains Julia, the standard library, all its dependencies, and then you can just take it, copy it to a production machine, and um, and that's it, right? So the advantage is that you do not need to install Julia on your deployment machine, right? But the disadvantage is that you need a C compiler on the build machine, right? So the machine on which you are bundling this package, the machine on which you are creating this bundle, you will need a C compiler in that machine. But once you have created that bundle, you can just copy it to a production server without having to install Julia or install the packages on that machine, right? And so this might be useful in certain situations where your deployment process is deploying to a standard build of a server which doesn't have Julia installed, and you can just push this Julia bundle, right? uh, One other downside is that process is not OS agnostic. So if you're deploying to a Windows server, you need to build it on a Windows machine. If you are deploying to a Linux server, you need to build this on a Linux machine, right? Uh, and there is a webinar that where Christopher, who's one of the developers of Package Compiler, describes how to use it, and it's quite a comprehensive uh, video that walks you through all the options that that the that this product has. So watch this video if you're interested in package compiler. It's a very detailed look at what is required, right? Right. So if you do use package compiler, right, to create these bundles that you deploy onto production, uh, it's important to consider relocatability, right? Because Julia being a dynamic language, it's relatively easy for libraries to hard code paths, right? So maybe you load a binary from some disk, or you load a DLL or an SO from some location on disk. you might have some data that you load at runtime, right? Uh, and it's very easy to uh, hard code these at, that gets built into the bundle at compile time, right? So when you then move this bundle to a different machine, it doesn't work. And that's a common problem. So if you're using package compiler and your code doesn't work when you move it to a different machine, you typically have a relocatability problem. So the way around this is that, your package and all its dependencies should be relocatable, right? There shouldn't be any paths hard coded. And the way to do that is use JLL packages. So, don't write a build step for your package that, looks into some location on disk to create some artifacts. Don't do that. Don't store file paths or pointers in module global. If you want any paths at runtime, always load them at module init. Don't create a global, right? So if you have a Julia module, don't store any paths as a module global, right? Julia modules have something called an underscore underscore init function. And that's the function that runs at module initialization at runtime. And that's where you should do any path related lookups, right? So that you don't hard code any paths at compile time, right? Right. So package compiler is, one way of bundling Julia and its dependencies while you deploy code to production. Another way is running a Docker image. So instead of, creating a bundle as a package compiler artifact, you create a Docker image, right? And in that Docker image, you install Julia, either from OS repository, or you just download it from Julia Lang downloads, and then you instantiate your manifest, right? So the typical path of creating a Docker container for Julia is to start with a public Julia Docker image, which, if you go to Docker Hub and look for Julia images, you will find an image for pretty much every version of Julia. These images are typically created on top of Debian. If you want something on some other OS, then you might start with a base OS image and install Julia yourself. But it's pretty easy to start with the Julia images from Docker Hub, and then in your Docker build, you get your manifest from your source code repository. You instantiate that manifest, and then what you should do is you should always do a pkg.precompile at Docker build time, right? Many people typically tend to forget calling precompile. Precompile is a function in the package module, and it's available in Julia. So every time you instantiate a manifest in the Docker build in your Docker file, you should always run package precompile, so that when you deploy that Docker image, you are not you're not precompiling when that Docker image comes up, right? So your latency will be lower when that image actually runs. Right. So you have created a bundle with your code. You have deployed that. The question is then how do you scale that, right? So typically when people are running Julia processes, they want to use Julia for very large workloads. So workloads that take weeks of CPU time. And so typically you would want to run Julia in a large cluster, right? So Julia itself comes with distributed computing built in. So for example, it has things like PMAP or at distributed for that allow you to essentially take any piece of code and run it on a distributed cluster, right? A cluster where there is Julia running on multiple machines, right? So, and that is built into Julia. There is a thing called cluster managers, which is part of Julia that allows you to manage clusters of different kinds. So, for example, if you have SSH access across all the machines in your cluster, then there is something called an SSH cluster manager. Or if you have a Slurm cluster, then there is a cluster manager for Slurm, right? And so, so once you have your cluster running, then Julia's built-in distributed computing primitives make it pretty easy to run Julia code on all the nodes on your cluster, right? But the key question in many of these situations is, how do you actually get your code onto the cluster, right? Onto all machines in the cluster. So, you are running, on 1,000 nodes. How do you get your code on all those 1,000 nodes, right? And how do you ensure that all those 1,000 nodes are running the same exact code, right? So the actual solutions to that depend on the nature of your cluster. So for example, your cluster might have a shared file system. So if your cluster has a shared file system, then you put your Julia code, maybe the package compiler bundle, or just the Julia package directory onto this shared network drive, right? And then you load on each of those machines, you load your code from this shared network drive, which is common, which is a common strategy in things like a Slurm cluster. So HPC clusters or a cluster in a university, you might have shared file systems that give you access to shared code, right? If you're running your cluster on the cloud, on AWS or on Azure, then typically you would want to build your code into the image that those cloud machines are running. And so, for example, if you're running on Kubernetes, then you would build your Docker image that you would then deploy onto the Kubernetes cluster. If you're running on Kubernetes on the cloud, then Julia Computing's product, Julia Hub, is basically built to do that, right? So Julia Hub is our product that allows you to run large distributed, dynamically scaled jobs on various cloud systems. And so if you are interested in that, then go to juliahub.com and take a look. But even otherwise, you can run your own Kubernetes cluster, and then you would use the Docker build that we spoke about in the previous slide. Okay, right. Once again, if there are any questions while I am talking, feel free to use the chat window to ask. I'm watching them, and if there's anything I can answer, I will do that. Otherwise, I will get to the questions at the end of the presentation, right? Right. So, talking a little more about the cloud, if you're deploying Julia code in cloud, which most people want to do these days, Julia has different libraries that allows you to interface with the cloud systems easily. So for example, for Amazon Web Services, there's a package called aws.jl. For Azure, there's a package called azure.jl. I believe there's a similar package, although not that well developed, for Google Cloud Platform as well. And so using these packages, so using aws.jl, you can connect to any AWS service. So you can get data from S3, you can start EC2 nodes. And so, you can use Julia to manage these cloud clusters. You don't have to use, Python or Boto to manage the clusters to run Julia code. You can use Julia libraries to manage the cluster in which you're running that Julia code, right? We talked about Kubernetes. So if you're running Julia in a Kubernetes cluster, there's a package called kuber.jl, which has the complete set of Kubernetes APIs and entities. And that again allows you to manage a Kubernetes cluster from within Julia. So both your control plane as well as the code that you're running as in the pods can both be Julia, right? So if you're running on the cloud, then there are cloud native solutions to almost every cloud feature that you would want. So all of this that we talked about, works for both batch processes as well as long-running processes. But typically, if you're running long-running processes, you would want to expose them as HTTP services, right? And so Julia has a pretty well-developed HTTP stack. It includes routing and middleware. It lives in this package called http.jl. Not very creative name, but it's pretty clear what it does, I suppose. There's a tutorial by Jacob Cohen in last year's JuliaCon on building microservices in Julia, and that gives you, a set of patterns that you can use to create and deploy microservices using http.jl. So including the routing and the middleware that this package already has. And so, watch that if you're interested in more details. The one advice I would give you is that you should always front the Julia HTTP server by an Nginx or an HTTP or an Apache HTTPS reverse proxy. I wouldn't recommend using a Julia HTTP server directly on the internet. So front it with Nginx and then proxy it back to an HTTP, Julia HTTP server, right? That is how we run all our services at Julia Computing. So juliahub.com, as I said, our premier product runs on that same design where we have all our logic in Julia code as http.jl endpoints, and then that's fronted by an Nginx server that handles the actual internet endpoint, right? Instead of Nginx, you can use a load balancer that works the same as well. But have something that fronts your Julia service, right? Okay, so you can use http.jl to create REST or JSON services. If you wanted a UI, a web UI, you probably want a little bit of a framework beyond just raw HTTP. And some of these packages on the slide are built on top of http.jl, but they provide a framework for you to create your HTML widgets, your HTML front ends, right? So the first one I'll mention is Dash. So Dash, many of you may be familiar with, is a Python package built by the Plotly folks. People who build the Plotly charting library, and they built this thing called Dash originally in Python, but it's now been ported to R and Julia. And so the Julia port is called dash.jl, surprise, surprise. And so it's a fully featured, very well-designed web front end. It's a stateless service that's reasonably scalable, and it's probably the simplest way of getting a web UI in place, right? So it has, your charting widgets, it has all your typical HTML UI elements, and you can create Julia handlers. So you don't have to write JavaScript, you write Julia handlers, and everything is deployed as an HTML web app, right? And so it looks really nice, it looks slick, and I would recommend using it as the fastest way of getting a web UI getting a web UI up and running. If you have a larger application, take a look at Genie. Genie is a traditional MVC web framework. It's sort of in the same sort of space as Ruby on Rails or Django. And it has things like database migrations, it has a ORM framework, it has web handlers, authentication plugins, the whole works, right? And so if you're building a traditional web application, then Genie is perfect. The author of Genie also has built something called Stipple, which is built on top of Genie, and it's a dashboarding solution, right? So it's like Dash, It's less complex than full-featured Genie, but again, it allows you to quickly create dashboards, without having to worry too much about writing HTML or writing JavaScript, right? Um, and last but not the least is WebIO, which is probably one of the oldest UI frameworks that we have in Julia. And it's good for creating quick reactive web widgets, which you embed in maybe a IPython, iJulia notebook. And WebIO is good to create these small widgets that you embed in other places, right? Okay. So moving on from HTML and web UIs, most production environments, you will agree today, are heterogeneous. No one's doing a pure Julia service. Even if you write most of your code in Julia, there is going to be always be other parts of your ecosystem that you have to interact with. And Julia provides a pretty rich set of tools to interact with uh, other things in your environment. So the one strategy that I recommend as sort of the baseline is to use HTTP REST APIs, both into Julia as well as uh, from Julia onto other systems. So for example, if you have, a highly proficient JavaScript front-end team, they would write your front-end in Node.js and JavaScript, and you would maybe then call into Julia. You would create your Julia service as an HTTP REST API, maybe a JSON API, and your JavaScript Node.js application would call into Julia using an HTTP REST API, right? And that's a very traditional architecture that I know many of our customers are using, and that helps manage your team structures, your skills as well, where your UI or your web front-end team develops in the tools that they know best, while your optimization or your simulation team uses Julia to develop the backend, right? And that works really well. Julia also has a really high quality ZMQ interface. So ZMQ is somewhat like sockets, but at a higher level. So you can use ZMQ from pretty much any language, from Java, from Python, from Ruby. And so you can connect to and from a Julia service using ZMQ. And again, that's something that's easy to do, and it gives you a very high performance system that you can talk to heterogeneous language services. Julia also has very good foreign function interface, which I imagine many of you know about. So you can call into Java or Python or C code from Julia code very easily, right? And that should be obvious by now to most of you, so I won't spend too much time talking about it. More interesting is, Julia has interfaces into sort of the large enterprise messaging and computation framework. So for example, from Julia, you can call into Spark. You can run Julia jobs as Spark jobs. You can manage Yarn jobs as Julia processes. You can run Julia processes as Yarn jobs. You can load HDFS files. You can listen to Kafka messages from Julia. You can send Kafka messages from Julia as well. All of these things, if you don't know what they mean, don't worry. But if you do use them, I hope it's useful to know that you can use Julia for all these sort of traditional enterprise systems that you might have installed on your network, right? Last but not least, if you're deploying anything to production, you probably have your data in some database, relational or not. And at this point, people have been working on Julia database libraries for many years now. And so our database libraries are as good as what you would get in other languages. So we have drivers for MySQL, for Postgre, for Oracle. These drivers wrap the C drivers, so they are as performant as the C drivers. We have drivers for the non-relational databases as well. So for Mongo, for Redis, for ClickHouse, uh, pretty good quality drivers. Uh, I think the ClickHouse driver is native Julia. The Mongo and the Redis drivers wrap the C drivers as well, right? And again, they are highly performant. You can get your data from Julia, right? And for sort of the strange databases that you have installed that not many people use, that we don't have drivers written for yet, you can use ODBC or JDBC depending on what you are comfortable with, basically to allow access to almost any database, right? Any database uh, under the sun has either an ODBC or a JDBC driver. And so you can use one of those from Julia and get data out of that. So wherever your data lives, you can get it out to Julia and then load it, right? Uh, One other thing to say in this area is that over the last year and a half, the tables.jl ecosystem has grown and matured heavily, right? So earlier, if you used a database driver or you loaded some data from disk, your data would, be sometimes, an array, sometimes it would be a data frame, sometimes it would be a nested set of arrays, sometimes it would be dicts. And so you would have to worry about, how to convert it into the way you want to do your analysis. Over the last, as I said, year and a half, the tables.jl package has been used widely across the entire ecosystem. And so now most analytical packages as well as most data packages use tables.jl as their intermediate representation, right? So most of these database drivers will give you the data back in a tables.jl interface, right? And using that, you can convert it into a data frame. So a data frame can take a tables.jl object and convert it to a data frame. And an arrow table can take a tables.jl object and convert it to an arrow table, and vice versa. You can get an arrow table as a tables.jl object and run queries on it, right? So the use of this tables.jl interface gives a consistent view into two-dimensional data within the entire Julia ecosystem. And that makes it so much easier to um, uh, have a consistent view of data, both from your data source side as well as your data analytics side, right? So that's pretty much all that I had to talk about. I am keen to listen to your stories for the rest of the time that I have. Tell us uh, what problems you have, what solutions you've come up with, and we can discuss it together. There's a question from Walter on chat saying, is there something in place for multidimensional or OLAP data cubes? Not really, no. Typically, if you have an OLAP data, I would suggest using an ODBC driver to it and get the data out in whatever version the ODBC driver gives you. So the ODBC driver will probably give you a two-dimensional view into your data. That's probably your best bet. I don't think there is anything that is that works specifically with data cubes. You would have to probably write maybe a couple dozen lines of code to convert an input into a three-dimensional array, for example, in Julia to analyze. But nothing automatic that I know of, right? So yeah, that's
Yeah, thanks.
right.
ODBC usually also has often trouble. I mean, I've seen all sorts of ugly hacks, you know, having SQL databases linking to cubes and stuff like that, and so that you can send the MDX through the mirrored database
Yes.
to the cube and stuff. But it's interesting because there's so much cube data or multidimensional data being used for the last years even, that there's still somehow nothing out of the box of all these ODBC developers and wrapper developers. Very interesting.
Yes. I mean, so that's an interesting thought, and you're right. You know, there is a lot of cube data, but I suppose you know most so there is a lot of OLAP data that a lot of people are, you know, currently working with, even today, working with OLAP data, creating OLAP data. But a lot of the sort of excitement, quote unquote, if I can use that term, in modern data processing is just to use things like Spark or SGFS and, you know, run sort of queries in memory, right? Rather than use processed OLAP. If that makes sense, right? So you use a data lake instead of an OLAP, and you know that's what most sort of hype is around, right?
Absolutely, I totally agree with you. But it's so fascinating because I have a little bit of a different background. I'm more from the finance side.
Yeah.
And you know, controlling and finance, and there it's all about aggregations and
Exactly.
analysis,
Sure.
and you know, you're not really interested in unstructured data, so to speak.
Yeah.
But you are, when you're talking about, for instance, financial institutions, there's a huge amount of this semi-structured or even, so to say, structured data that gets processed in cubes, because it's the most efficient way to do it, and that's
I mean, and again, this is it's a fascinating topic, and I don't have a clear answer. But maybe one way to look at it is all the analysis that people do on these things. People just buy a Power BI license.
legacy. Yeah, exactly. Power BI. That's what exactly what you hit the
So maybe
nail on
that's
the
why
head.
nobody uses open source, and so there is no sort of ecosystem around it, honestly, right? Even in Python, I don't think there is an ecosystem around these kinds of data very much, right? Pandas and
The only way I can do it currently is I'm using ADO-MD objects, basically. So ADO multidimensional objects, and but then later on you have to slice and dice these according to your requirements to get it into 2 dimensions. But still, it's basically also legacy product. You know, it's fully Microsoft.
exactly.
You're fully in the Microsoft cage there. Yeah.
Exactly. So yeah, I mean, there isn't an open source ecosystem around these products, and that's a shame. I agree. You know, it's very useful, and a lot of people are using it. But yeah, even if you're
Thank you.
using Pandas, you know, you'll find the same sort of problems. I imagine.
Yeah, it's not nowhere existent. I mean, I would gladly, you know, do the things I need with maybe Python and then push them somewhere else. But you're really stuck in vendor lock basically there somehow.
Sure.
Yeah.
Yeah, that's true. I mean, I wouldn't doubt it at all. I don't have a solution, but yeah, thanks for your question. That's it's an interesting discussion.
Thanks for your answer.
Yeah. Was there any other question? If not, I think I would thank all of you for your time. If you need anything from us at Julia Computing, do write to us. You know, info@juliacomputing.com. If we can help you in any way, answer any questions about, you know, this topic today or anything in general. and find us on the open source Julia Slack or on GitHub. We are all, we are always participating in the typical Julia channels. Feel free to find us and ask us questions. Have a good evening and have fun with Julia. Bye-bye.